Okay, hello, welcome to the day 30 of our 30 integrals in 30 days. So in this video, we want to find the integral from negative 2 to 2 of the x squared divided by 1 plus pi raised to power sine of x, and that sine of x has been raised to power 3. Phew, this looks really crazy, right? Well, anyway, you can pause the video and try this first. Well, I'm going to do this real quick. This is going to be the same thing as the integral from 0 to 2 or x squared dx. Okay, and on getting that, this means when you integrate x squared, we're just going to have x cubed divided by 3, right? And we are taking that from 0 to 2. This is the same thing as 8 divided by 3. This right here is the integral of this function. Take note, you do not add an arbitrary constant because we are dealing with definite integrals. How did we possibly move from here to just x squared? Well, let me show you something really nice. Take note, this is true, right? The integral of a function at the top here divided by that, this is an even function, right? This is pi, just a number, raised to an odd function. This right here is an odd function. The integral is the same thing as from 0 to 2 of just the even function. This is from negative 2 to 2, so you take half of that interval, all right, from that. Okay, so let's see how we got to this point. Okay, so if you are given to find the integral from negative a to a of an even function, let's say an even function of x, right, divided by 1 plus b raised to the power of an odd function, let's say an odd function of x, okay, and we have to do that over the x variable where x starts from negative a to a, all right. Take note, this is what we did earlier. This was an even function of x, and this power here is an odd function. Take note, this b as a base here must be a positive number, all right? That's 1. And also, take note, this place must be 1 before you can apply this trick right here. This place must be 1, and then this interval must be alternating, that is from negative a to a, all right? Okay, so if you are given that, well, I'd like to call this a name. Let's just call this I, right? And when we do that, we put it somewhere on top. Let's say we put it just, oh, sorry. We put it here. We call that I, right? That is the integral we want to find. The integral from negative a to a of an even function of x divided by 1 plus b raised to the power of the odd function of x. Okay, let's do this real quick. Let's define I to be, take note, we have that I is what? The integral from negative a to a of, okay, so we have that to be I, and I can call that equation 1. Okay, let's call that equation 1. And now I want you to know this. We know that if we have the integral from, let's say, p to q, right, of some function, let's say g of t dt, okay, this in fact is the same thing as the integral from p to q of g of, now the input, we are going to rewrite it as p plus q, okay, minus t dt. This is from one of the properties of definite integrals, that if we have the integral from a certain number to a certain number of a function, right, let's say function of t in this case, and we have to do that over the t variable, this is the same thing as, then on this input, we can add the bounds of integration, add the bounds together, and then subtract t. This and that are, in fact, going to be the exact same thing. So we are going to apply that right here. That means this integral, this I, can be written as I to be the integral from, take note, the bounds will still remain, right, from negative a to a of, now, this function, okay, we are going to replace it with this particular input. That will be the even function of x. In place of x, I'm going to add these two together and then subtract x, right? So we're going to have negative a to a minus x, just by using this property right here. And we say that divided by 1 plus b raised to the power of the odd function of, in place of x, I'm still going to put in the same thing, negative a plus a minus x. And then we can put the dx over here. Okay, so this is very interesting. You notice that this will become I will become, well, you notice this negative a plus a will give us 0, right? Okay, so negative a plus a will give us 0. That will be the integral from negative a to a of the even function of, since it gives us 0, we just have negative x as the input, divided by 1 plus b raised to the power of, this will be raised to the power of the odd function, right, of still negative x as the input. And we can put the dx over here. Okay, that's nice. Now we know from some function properties, let me just write it here, I'm going to clean it up, that if we have the even function, let's say if f is an even function and we have the even function of a negative input, it is the same thing as the function of the positive version of that input, right? F of negative x is the same thing as f of x. That means f is even. If we have an odd function, let's say g, okay, g of negative x will be the same thing as negative g of x. This is when the function is odd. This one, changing the sign of the input doesn't affect the value or the result of the function, but this one, it changes the result to the negative, right? Okay, so that means that this integral I here will become, using that property, the integral from negative a to a, okay, of, well, since this is an even function, the output will remain the same thing as if the input was just x, from this property I've just written down right here. And then we say that 1 plus, well, b raised to the power of, the odd function of a negative input is the negative odd function of the positive version of that input, alright? So that will be negative odd function of x. And then the dx over here. Ooh, this is really cool. So let me just clean this up. Okay, great. Let's see what we've got. Okay, from here I can multiply the numerator by the odd function of x, and also multiply the denominator by the same thing, the odd function of x. So what I'm doing there is what we call multiplication by 1, right? Multiplying top and bottom of a fraction by the same thing is just like saying you haven't changed the fraction. We've been doing that a lot in our past days, all right? So this is going to be the integral from a to a, from negative a to a of, when you multiply this by the odd function of x, sorry, we are not multiplying by the odd function, we are multiplying it by b raised to the power of, sorry for that, b raised to the power of the odd function, all right, of x. So you multiply this by b raised to the power of the odd function of x, okay? You notice that this is a negative exponent and then this is a positive version of that. So if you are multiplying them together, this and that, we are just going to have 1, right? But let's write out the top first. So the top will be b raised to the power of the odd function of x times the even function of x, right? That is the numerator. And then the denominator will be, multiply this with that, we're just going to have 1 because the bases are the same, but the powers are negative of each other. Then we add it with, multiply this by 1, we just have this, right? B raised to the power of the odd function of x. Okay, that's really cool, and we can put the dx over here. Well, this right here, I'll call this equation 2. Okay, let's call this equation 2. So that is equation 1, and this right here is equation 2. So let's add the two equations together. So I will say let's add 1 and 2, right? By addition of the two equations, we have, we are going to add the left hand side and the right hand side, right? I here is the same thing as that, because from this property that gave us that. So that will be 2i on the left hand side to be, well, this is the integral from negative a to a. This has the same bound, so, and they are integrated over the same variables. That means we can combine them without any problem. The integral from negative a to a of, so let's see, the denominators are the same, 1 plus b raised to the power of odd function of x, 1 plus b raised to the power of the odd function of x. So when you are adding two fractions together, given that the denominators are the same, you just maintain the denominator, right? You do not add the denominators. So that will be b raised to the power of the odd function of x. And then we are going to add the numerators like this. So you notice this is going to be the even function of x, right? The even function of x plus b raised to the power of the odd function of x times the even function of x. Oh, this is getting interesting. So you just tell me this is going to be the 2 times the integral, well, from negative a to a, okay, negative a to a of, well, the even function and the even function are common in the numerator, so we just have 1 plus b raised to the power of the odd function of x. Okay, and then we multiply that by, take note, the even function of x, since even is common at the top, and then we divide this by 1 plus b raised to the power of the odd function of x, and then we put the dx over here. What do you see? This and that are exactly equal to each other, so we just cancel it and we are just left with what? The even function of x. Okay, so I'd like to clean this part. Let's see. Okay, let me just clean this part, right? So you can take a screenshot of this. I'll clean this part and we are going to continue here. All right, so this means that 2 times I is the same thing as, well, the integral from negative a to a of this and that are gone, so we have the even function of x, right? And we have to do that over the x variable. Wow, this is good. But you notice we were asked to find the integral of this function, which we noted as I, right? It wasn't 2i, it was just I. So how can we get I from here? Well, we can divide both sides by 2, right? And we get I to be 1/2 of that. That is still without any problem, okay? But I wouldn't like to go that way. I would like to use another property of the definite integrals, that if we have to find the integral, okay, of a symmetric interval, let's say from negative, let's say a to a of an even function, let's say t, right? Maybe let me just call this c. Let's make it different a little bit. Of an even function of t, dt. This in fact is the same thing as 2 times the integral from 0 to c of the even function of that same t, okay, dt. So that is just like saying you cut the interval into 2 equal parts, right? From negative c to c is the same thing as from 0 to c if you multiply it by 2. Good. So that means this will become 2 times the integral, okay, 2 times I, to be, well, 2 times the integral, let me indicate it for you to see, 2 times the integral, right, from 0 to a, okay, of that same even function of x, and we are doing that over the x variable. So as you can see, these 2 and these 2 can cancel. Ladies and gentlemen, the integral becomes the I equals to the integral from 0 to a of the even function of x, and this right here is the result. So given any kind of crazy function, given that this is a symmetric interval from negative to positive version of that lower bound, and then we have an even function at the top divided by 1, all right, plus a positive base raised to the power of the odd function of x, and we are doing that over the x variable, given that x is the variable there. This is the same thing as the integral from 0 to a of that numerator, which is just the even function, and we are doing that over the x variable. So with this, you can construct any kind of crazy integral that you'd like. So with that, I hope you can go back and take a screenshot of that, right? Forgot to inform you. That means this integral, that means this integral from negative 2 to 2 is just equal to, as we did earlier, the integral from 0 to 2, okay, of x squared dx. And of course, we did it earlier, x over 3. This right here is the antiderivative of this function. So it doesn't matter how crazy it looks. You can go ahead and construct as crazy as it may be, but take note of this structure. Okay, thanks for watching. Please share this video. Don't forget to subscribe to my channel, right? Don't forget to subscribe to my channel and let me know what you think about this video, right? And you can suggest other integrals you'd like us to do. This is not the end, right? Though we're stopping the 30 days, but we're still going to be doing some interesting integrals. Okay, let me see your comment section and everything you want. Thanks for watching. Please subscribe to my channel.